Hi, so we are going into Application Maths 2018 Paper 2. Just a reminder, these videos are created to help you study, so it's always a good idea to have the question paper in front of you. As well as that, it's a good idea to have tried each question before you watch my explanation of them, but if you're completely stuck, obviously watch along, see what I'm doing, maybe pause it once you've got to the point where you're like, oh, okay, I've jogged my memory, that's what I'm doing. But we'll get going. So we've got Jack bought a car 3 years ago costing £1,400. The car has decreased in value by 13% each year. Part A, calculate the current value of the car, giving your answer to two significant figures. Right, so we know that it's decreased in value, so decrease means go down. That's our first important part. And 13%, so if it's decreased by 13%, that means it is now worth 87%. That's how much it's losing every year, or that's how much it's worth after the end of each year even, right? So we are going to calculate the current value of the car. So we change that into a decimal by dividing by 100, so 0.87. Our next important thing is here, so it's 3 years ago, so that means it's 0.87 to the power of 3, and then we times that by its original value. So when we do that, we get the answer of £921, 9042. Right, so we need to put that into two significant figures. So remember, when we're looking at significant figures, we're looking at that's our first significant figure, that's our second one, so our third one decides what happens. So this one here, the 1 means the 2 stays as it is, so it becomes £920. Right, so if we're looking at part B now, so it says calculate his loss as a percentage of the original price. Right, so Jack sold his car for £950 and he bought it for £1,400. So what we need to do is work out the difference, so how much he has lost since he bought it. So we're doing 1,400 take away the 950, which is 450. So that is 450 over the original, which is 1,400. To change a fraction into a percentage, we have to times it by 100. And when we do that, we get 32%. It's 32.1, but if we round it to the nearest whole number, we get 32. So for this, we are going to now look at the marks. So your first mark is for identifying your multiplier, which is 0.87. Your second mark is for knowing that it's to the power of 3. Our third mark is for multiplying that through correctly to calculate the correct value. And then our fourth mark is for rounding to the correct number of significant figures. And then for part B, our first mark is for knowing that we have to calculate the percentage loss, so that it is 450 over 1,400 and then times it by 100. And then our second mark is for the process of getting to the correct answer. Okay, so question 1 down, 6 marks down out of 65, lots still to go, but here we go, on to question 2. We have the number of podcasts Omar downloaded each month for a year is shown in the table below. For this data, we need to calculate the median, lower quartile, and upper quartile. So to do this, first thing we need to do is write it out in order, because our quartiles and our median make no sense unless it's in numerical order, so we need to start at our smallest and work up. So if we look in our table, we're looking for our smallest possible number, which is 5. And as we do each one, if we score it out, it means we won't accidentally count it again, and it makes it really obvious which ones we've missed. So we had 5, our next one is 9, next smallest is 10, then we've got 12, then 13, then we've got 19, and we have 19 again. we've got 21, we have 22, 26, 28, and 34. Another good check at this point is to check that the number we have the same number of numbers in our list as we do there. So there are 12, because there's 2 rows of 6. So if we count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're good. Right, so we need to find our median. So the median is the number that's in the middle. So if we kind of look, we know we've got 12. So if we split that into two kind of halves, we end up with 6 numbers either side of the middle. So if we've got 1, 2, 3, 4, 5, 6, our middle is here. So the middle is there if we're looking into two halves. So that means that our median is in between those, and because they're exactly the same, it is going to be 19, whereas if those were separate numbers, we'd have to find the average. So now our lower quartile, which is given as Q1, that is looking at the median or the middle of this half, so the middle of the bottom half. So there's 6 numbers in our bottom half, so it's going to be in here. So in here is where we've got our Q1. So this time we have 10 one side and we've got 12 the other. So halfway in the middle of those is 11. So that's what our Q1 is. It's 11. And then looking at the other side, it's going to be 3 numbers in as well. So we can either go from our middle or from the end. So we've got in there. So this is where our Q3 is. So it's kind of in there. So we can see kind of really visually that we've split it into equal bits. So it's going to be right in the middle of 22 and 26. So if we think about it, there's 4 numbers in between, so it's going to be 2 up, so it's going to be 24. Right, so that's us for part A. So we need to construct a box plot for the data. They do give you an extra diagram in case you mess up this one. Right, so let's give this a go. I'm going to make my line a little bit thicker, so give me a second. Right, so for our box plots, we need our lowest value, we need our Q1, our median, and our Q3, and we need our highest value. So our lowest possible value here is 5. So if at 5 we do a line on our box plot, we have our highest value, which is 34. So if we make a mark at 34, there. And then I'm going to kind of color code mine just to make it really obvious with what I've done. So our Q1 was blue, so I'm going to put that in blue at 11. So there we go. The thing to be careful of here obviously is the scale. So we can check there are 5 boxes here and 5 in our numbers. So each box is worth 1. But you need to make sure that that's the case every time and don't just assume it. So our median is 19, so that goes here. And then our last one, our Q3, is 23, so that is here. And then we can join it up and make a nice colourful box plot. You should be using a ruler when you're doing this. I don't have one at the moment because I'm using an iPad, so it's really difficult. And then there we go, that's our box plot. And then if I just kind of draw it over to make it black, there we go. So you can see we've got our box, which is here, which goes between Q1 and Q3, and then we've got our whiskers out either side. So our marks for these parts of the question. So for part A, we get 1 mark for our median, and then we get 1 mark for both the quartiles being correct. So you need the 11 and the 24 for the second one. And then for our box plot, we get 1 mark for our ends being correct, so the 34 and the 5, and then the second mark is for the box being correct. So that is us for question 2, so we'll go on to question 3. Right, so Ross is changing his internet package. The table below shows the internet packages that he is considering. We need to use the fact that Ross requires a minimum speed of 52 megabytes per second, at least 50 gigabytes of usage, and a 12-month contract. Ross wants to choose the one that gives the lowest overall annual price, so remembering annual means per year. Which package will he choose? And use your working to justify your answer. So the important bits are the annual price, and then 12-month contract, 50 gigabytes of usage, and 52 megabytes per second. So using this, we can kind of eliminate some straight away. So if we start by looking at the speed, if it's less than 52, we can get rid of it. So this one, which is 38, that one immediately, that whole kind of package C doesn't need to be taken into account. Right, so what one can we eliminate next? So we've got at least 50 gigabytes of usage. So looking at the usage, not enough. And the other 3 that are left are fine. So we can eliminate that top one, which doesn't give us enough data. And then looking at our last bit, which says we want a 12-month contract. So our contracts, that's 12 months, so that's okay. That's 12 or 18, so that's fine. 24, too long, we don't want that contract. There we go. So we now need to work out which one is the cheapest annually. Right, so if we're looking at plan B, we have a monthly line rental of £8.95. So we have our £8.95. And we have our monthly broadband cost, which is £20.99. So those are monthly, so for a year we've got to times it by 12. And then we're also going to have to add on our initial fee, which is £59.99. When we work that out all together, we get that it is a cost of £419.27. And then for D, so we've got our £7.99 and our £18.99, which are both still monthly, so it's times by 12 again. And then our initial cost, which is £109.99. So altogether for the year, that comes to a total of £433.75. So we know that he should choose the package which is cheaper, which is B. So marks for this question. Our first mark is for eliminating and the packages that don't work, so getting the fact that it's just B and D that we work out. Our second mark is for calculating the total cost of one of the packages. So either working out package B that's $419.27 or package D is $433.75. And then our third mark is for getting the other answer and making the decision. So the $419.27 and then making the decision that actually the package B is better than package D. That's us for question 3, so we're going to go on to question 4. We have Nicola, who has joined a gym. Our pie chart shows the proportion of time that she will spend on each type of workout exercise. So for part A, we have to calculate how long in minutes she spent on resistance training. And we know that she spent 1 hour and 45 minutes exercising in the gym. So for part A, if we look at the resistance training, looking at our colors, so resistance training, so that's this one. So we know that it's 144, and we know that the total of a circle is 360. We have to multiply it. It asks in minutes, so we have to multiply it by the number of minutes. So we have 1 hour and 45 minutes. An hour is 60 minutes. So altogether that's 105 minutes. So 144 divided by 360 and then times it by 105 gives us 42 minutes on resistance training. So that's part A. Part B, she spent 21 minutes exercising on the treadmill. Her average speed was 6.6 kilometers per hour. Calculate the distance she ran on the speed mill. So we need to know this one is speed, distance, time. So distance is equal to speed times time. We have an issue though, because our speed is 6.6 kilometers per hour, but our time is in minutes. So to change a time from minutes into hours, we need to know that time is, there are 60 minutes an hour, so we divide it by 60 to get it into hours. So it is 6.6 times by 21 over 60. And so we get 2.31, and it is going to be kilometers. Right, so part A, we get our first mark for knowing how to calculate the time, which is 144 over 360 times 105, so that first part. And our second mark is for processing that and getting 42 minutes. For part B, our first mark is for knowing that the time has to be divided by 60 to change it into hours. And then our second mark is for processing that and getting to 2.31 kilometers. On to question 5. 3 tons of sheep food will last 18 days if we've got 350 sheep. The number of sheep increases by 100. A. How long will the same weight of food now last? So we know if we've got 350 sheep, it will last 18 days. So the number of sheep is going to increase, and it's going to go up to 450, but so we're ending up with 450 sheep, and we're trying to work out how many days that'll last. So we've got a couple of ways to do this. This is an indirect proportion. If we think about it, as the number of sheep go up, the number of days is going to have to go down. So as we do one thing to one side of our ratio, the opposite is going to happen to the other side of our ratio. Well, if we've got one sheep, it's going to last 350 times as long. And this is our calculator paper, so that's not a problem. So we get that would be 6,300 days. So it lasts an awful lot of time, awful long length of time. And then if we think about this side, we have times by 450. So as we're doing that to one side, we have to divide the other by the same. And that gives us 14 days. So therefore, it will now last 14 days. It's always a good idea to kind of communicate your answer in a way that makes a lot of sense. It makes it easier for the marker, and they're just human and like it kind of to be as easy as possible, to be honest, and it makes it as obvious to them as possible that that is the correct answer, and that is the answer that you've come to. Right, so for part B, storage container for the sheep food is in the shape of a cylinder with the dimensions shown below. We have to calculate the volume of the cylinder. So we have volume is equal to pi r squared h for a cylinder. You need to be careful because this here is the distance across the cylinder, and that is our diameter, not our radius, so we have to half it. So it is pi times half of that, which is 1.9, which has got to be squared, and then we times it by 9.7, and that gives us an answer of 110.009 meters cubed. So we can round that to 110 cubic meters. So for that one, going over our marks, we get our first mark for part A for knowing that it's inverse proportion, so knowing that as one gets divided, the other one gets multiplied. That's our first mark. Our second mark is for getting the fact that for one sheep it would last 6,300 days, and then our last mark for part A is for getting the answer 14 days. For part B, our first mark is for knowing this line here, so pi times 1.9 squared times 9.7, and then our last answer is last mark is for the answer. For part A, there's nothing kind of tricky in the notes. For part B, however, you need your correct units to get that second mark. If there is no unit there, then you do not get that second mark for part B. We also, it says that accepting any final answer with legitimate rounding, which is good, and that is us. So if we go on to question 6. We have Ali, Kate and Jim are paid to deliver leaflets advertising a new restaurant. They share the money they were paid in a ratio of 3 to 5 to 7. We know that Jim received £154. Calculate how much the restaurant paid in total to deliver the leaflets. So we have Ali, we have Kate, and we've got Jim. So we know that Ali got 3 shares, Kate got 5, and Jim got 7. And we know that those 7 shares came to £154. So if we work out our total number of shares, so that's adding up all our kind of numbers there, we know that altogether there were 15 shares. So there's a few different ways to do this. We could work out how much Ali and Kate both get and then add them together with Jim's, but I think the way that makes most sense is we know that 7 shares is £154, so we can work out 1 share, which is going to be £22. So the total amount is going to be equal to 15 lots of £22, which is £330. Right, so marks for question 6. The first mark is for knowing that 1 share is £22, and then the second mark is just for your final answer. So we'll keep going on to question 7. So looking at question 7, we have Sam drives from Paris in France to Zurich in Switzerland. He knows the car will cover an average of 47 miles per gallon of fuel. The fuel tank holds 50 litres of fuel when it's full. Is 650 kilometres from Paris to Zurich. Will he be able to complete his journey on 1 tank of fuel? Use your working to justify the answer. So we know that 1 mile is the same as 1.609 kilometres, and 1 gallon is 4.545 litres. So we know that the distance is 650 kilometres, but our fuel is in miles per gallon. So if we change, we're going to have to change that 650 kilometres into miles, and to do that we're going to have to divide by the 1.609 kilometres. This kind of is working like currency exchange. So if you're converting to something, you are multiplying, and if you're converting back, you divide. So because we know that 1 mile is 1.609, we have to divide because we have kilometres and we're trying to change back into miles. So when we do that, what we get is 403.977, and it does keep going, and that's miles. So we know that the tank holds 50 litres of fuel, but we have 47 miles per gallon, so we're going to have to change our litres into gallons. So we have 50 litres, and we're going to be dividing again, and it's 4.545 that we're dividing by this time, and we get 11 gallons. It is slightly more than 11, but not much, right? So now if we figure out 47 miles per gallon, so 47 times 11, which is 517 miles. So we can make a comment because we know that the journey is only 403.977 and the tank holds 517 miles worth of fuel. So we can say, therefore, yes, as 517 is more than 403.977. Right, so looking at where we get our 4 marks for this question. So your first mark you get for being able to work out kind of the distance into kilometres, from kilometres into miles. You get 1 for figuring out how many litres the tank will hold in gallons. You get 1 for working out how many miles the tank will go, and then the last mark is for your comment. For this question, there are alternative strategies for how you can do this. So you can also work out how many litres, kilometres per litre that will be for fuel, and then you can work it there. I've changed things into miles and gallons, but you can change everything kind of into metric. You can also kind of do a lot of different ways to get there, but as long as you get to the correct answer, you'd be okay. If you want to have a look at the marking scheme, if you've tried this a different way, there are 5 different strategies for how this question is answered. But this is the one that I would tend towards, so it's the version that I've put here. Okay, so we'll go on to question 8. Scott decides to buy a new trail bike. He needs to buy a frame, a handlebar, a pair of pedals, a saddle, 2 wheels and 2 tyres. Different retailers offer these parts. The prices in pounds are shown below. So Scott can buy his parts from different retailers. The frame costs £2,640.95. Calculate the minimum possible cost. So we're going to have to go through and work out what the lowest value for each different thing is. So the frame, the cost we already know. The handlebar, so we're going to look for the cheapest one. So looking in our handlebar column, our cheapest option is going to be this one here, £55.49. We need a pair of pedals, so careful here, it does say that it is a pair. So cheapest possible pair of pedals is Bikes to Go. Wheels is the next thing kind of in our table, so if we look, 2 wheels and the wheels each, so we need to be careful and remember obviously that we're going to have to double that. So our cheapest one here is the bottom one at £44.49. We need a saddle, so looking for the cheapest possible saddle, that's this one here, £41.66. And then tyres each, and obviously again, so each, and we've got 2 tyres there, so this one again, same as with our wheels, we're going to have to double, and it's that bottom one again. Right, so let's work out the cost of this bike for Scott. So the cost is going to be equal to, so we've got our frame, £2,640.95. We have our handlebar, which is £55.49. We've got our pedals that come in a pair, which is £33.33. And then we've got our wheels, so we need two of these, two lots of £44.49. We've got our saddle, which is £41.66. And then we've got our tyres, which again we need two of. So 2 times £49.99. So putting that all together, we get that the total price for this bike would be £2,960.39. So before we go on to part B, we're going to go through where the marks come here. So your first mark is for knowing how to pick the cheapest prices and adding the cost of the frame. So kind of the stuff we've done there and there. So here, this bit, and then knowing that you've got to add all those together, that's your first mark. And then your second mark is for getting the answer. Okay, so we'll go on to part B, and for part B we're going to have to use the answer for part A. Remember, even if you don't get the part A correct, you can keep using the answer you have and then work it from there. So we have, Scott can't afford to pay for the bike all at once. Cash price of a complete bike from EP Bikes is £2,991. He chooses to buy the complete bike from EP Bikes as they're the only retail offering a finance package. The finance package consists of a deposit of £15 of the cash price, 36 payments of £76.50. Calculate how much more this finance package will cost compared to the minimum total cost. So we need to remember from part A what our value was, and we had that the minimum one was £2,960.39. So that's there, but just to kind of compare at the end. So we have our 15% deposit of the cash price. So we have 15% of our £2,991. So using your calculator, you can either do this as a decimal, because this is a calculator paper, so it would be 0.15 was what we're putting in, and we get that the deposit is £448.65. And then we've got to work out all his payments, so it's 36 payments, all at a cost of £76.50. So 36 times £76.50, which gives us the answer of 2,754. So the total cost is going to be those two added together, so the 2,754 plus the £448.65, which is £3,202.65. So we need to work out the difference to figure out how much more it's going to be. So our extra cost is our £3,202.65. Take away that £2,960.39, and we get that that answer comes to £242.26. So the marks for part B, first mark is for knowing how to calculate a finance package, so knowing that you've tried to find the deposit and trying to find the total. So kind of roughly there. Whether those answers are correct or not, then it's kind of a bit different. You wouldn't get all the follow through marks, but if you had different bits there, you would still get the mark for showing you've kind of understood what a finance package is and how you've got your deposit and the payments. So your first mark was there. Your second mark is for 15%, so the £448.65. The third mark for this part of the question is for getting to the total cost of the finance package, And then your final mark for this question is for getting to the answer for the extra cost being £242.26. Right, so we're going on to the next part of this question. So there's a part C, and there is a part D as well. So we'll keep going on to part C for question 8. Right, so for part C, we've got Scott trains at the velodrome on his new bike. He records his top speed in kilometers per hour for each lap. 6 of these speeds are shown below. For these speeds, calculate 1, the mean, and 2, the standard deviation. So for our first part of our question, we've got to calculate the mean. So that is x with a little line on the top. And we get that by adding together all of our values. And then once we've added them up, we divide them by how many there are. So we've added together a total of 6 numbers, and when we do that, we get that our mean comes to 59.6 kilometers per hour. Right, so that's 1 mark there. So on to part 2. So with standard deviation, there are a couple different formulas. I use the one that's given second on the formula list. I know that a lot of people use the one that is x take away the mean, but I'm going to go through it the other way. As long as you have the same answer when we get to the final bit, then we're okay. So I have my x values and I work out my x squared values as well. So we've got 61.2, 58.3, 59.1, 58.8, 60.4, and 59.8. So we will need to add those up, but we also need to work out what they are when we square them. So first one, when we square it, we get 3,745.44. Second one, when we square it, we get 3,398.89. Then what we get for our next one is £3,492.81. Good job, we have a calculator for this, right? 58.8 squared is 3,457.44. 60.4 squared, we get £3,648.16. Well, it's not pounds. Don't know where that came from. Just been doing a lot of questions with money. So, and then our last one is £3,576.04. So we need to add these all up. So 61.2, add 58.3, add 49.1, add 58.8, add 60.4, add 59.8, and we get 357.6. And then when we add up all of our x squareds, we get 2,318.78. Right, so the formula I use for standard deviation and that I teach is standard deviation is equal to the sum of x squared, take away the sum of x squared over the number of data all over n minus 1. So this is where we need to be careful, so kind of identifying what it is. So sum of x squared, so this bit here, that is this number there because we've added together all our x squareds. So when we start substituting in, we get the square root of 21,318.78. Take away, and then this next one, sum of x squared, is this. squared. So we've got 357.6, which we've got to square. So 357.6 squared, all divided by 6, because there are 6 pieces of data in our sample. And then n take away 1, so we've got 6 pieces of data, take away 1, which is 5. So our answer there is 1.078, which will round to 1.08. So that is our standard deviation. So our marks for part C of this question. So we've got our mean, which is 59.6. That's your mark for part A. For part 2, part 1 of question C even. For part 2 of question C, for this method, you get your first mark for getting to the point of having your x, the sum of x and the sum of x squared. Second mark for correctly substituting in, and then your third mark is for the correct answer. So we're going to have to use these in part D, because we'll always, if we've got a question like this, have to do a comparison between our standard deviations for 2 different sets of data. So going forward on to part D. Right, so as you can see, we've got part D. So we've got Scott had a mean top speed on his old bike of 57.3 kilometers per hour and a standard deviation of 1.21. Make 2 valid comments comparing his top speed on the 2 different bikes. So over here I have the data from part C that we had. So we worked out the mean was 59.6 and the standard deviation was 1.08. So we need to make a comparison between them. So we can see that looking at the means, the value is lower on his old bike. And remember, with these questions, we've got to make a comparison that references the context of the question. So Scott has a higher top speed on his new bike. On average. Okay, so just making a comment to say like that the mean is higher is not enough. You have to state it with the context of the question. So it's talking about the speed and it's talking about the bike. So your sentence kind of has to speak about those 2 things. And then our second comment, we have to look at our standard deviation. So standard deviation, remember, it's talking about how consistent our results are or how varied they are. So we can say that Scott's top speed is, so we've got 1.21 on the old one and 1.08, so it's lower, so that means it's more consistent. On the new bike. Looking at the marks here, it is straightforward. So they've asked for 2 valid comments comparing his top speed on the 2 different bikes. So we get 1 mark for comparing our means and 1 mark for comparing the standard deviations. Of course, we have to remember and take into account that again, I can't say it often enough, you have to reference the context of the question to actually get your marks. Right, so that is us finished learning about Scott and his bikes, so we can go on to question 9. Okay, we have a factory produces cans of tin beans. The table shows the list of tasks and the time taken to complete them. We have to complete the diagram below to show the tasks and times in the boxes. So we've got our first task, which is C, which is here, which is our one that requires nothing to have happened beforehand. So our second part is going to be the one that also has nothing required beforehand. So in which case that is going to be F, which is the sauce. So we can write in there F, and we put our 900 minutes. So now kind of starting to fill in more. past the one that's next to C is going to be the one that requires C to have happened. So this is the one here. So the preceding task, that means C has to have happened beforehand. So A is what is going to go in this second box on our top line, and that is 500 seconds. So keeping going, what requires A to have happened? So here, A in our preceding task, so put the beans in the tin, so H, which takes 2. So that's going to go here. Right, so then we can figure out what needs to go past next to our F. So looking for what has to have F as a preceding task. So if we're looking down here, we've got that, which is put the sauce in the tin, so that is E. And the time for E is 2. So now when we've got our combined into kind of one line, so we've got H and E, so we're looking for the one that requires those to have happened, which is here, B. So B, and that's 3, and now looking for what requires B, so that's at the end, so that's I, which is 300. Then what requires I to have happened, which is D, which is 5. And then our last one, which requires D to have happened, is G, which is 5 again. So looking at part B, we've got the factory manager thinks the whole process can be completed in less than 25 minutes. Based on the times given, is the factory manager correct? Use your working to justify the answer. So if we look here, we need to work out the total time, and this is in seconds. So here, 300, 500 and 2, so that's going to take 802 seconds for this branch of our precedence table. This one though is going to take 902, so that's what we're going to have to use. So we've got, for part B, we've got our 902 seconds, and then we've got our other parts, so we've got our 3 and our 300, our 5 and our 5. So when we add all those up together, we get that this task is going to take a total of 1,215 seconds. And so changing that into minutes, we're going to have to divide by 60, because there are 60 seconds in a minute, which gives us 20.25 minutes. So we can say yes, as 20.25 is less than 25. Careful here, obviously 20.25 minutes is not 20 minutes and 25 seconds. It is 20 minutes and 15 seconds, because 25 is a quarter, and a quarter of a minute is 15 seconds. So just be careful not to write that it would take, either leave it as 2.25 or 20.25, or if you're kind of worried about what's going on there. Right, so if we go on to part C, so we're keeping going again with our tin of beans and following it through the rest of its kind of journey. So here we go. Right, tins are packed in boxes. Each box has a dimension 60 centimeters by 40 centimeters by 15 centimeters, as shown in our lovely diagram. The boxes must be packed into shipping containers for shipping to Canada. The container has internal dimensions shown below. All the boxes must be aligned in the same direction. Calculate the maximum number of boxes that will fit in the container. Right, so we do need to consider two different arrangements of this. So we know it's got to be stored a correct way up because it says so. So we know in our height we can just work out how many will fit, how many 15 centimeters will fit there. So if we think about the height, or how many layers worth we can have, so it's 260 divided by 15, which gives us an answer of 17 layers up the way. So now what we need to do is we need to have a think about how many will fit on one layer. So this is comparing these two measurements with these two measurements. So we need to take into account if this one matches with this one, how many we could fit, but also if this one matches with this one. So you need to make sure that you're kind of looking at each orientation of the box. So we have like orientation 1. So if we have that, so that's if we've got the 240 and the 60 paired up, and then the 1250 paired up with the 40, then we get 240 divided by 60, which is 4. So we could fit 4 boxes along the way, and dividing by the 40 for the second one, we always are rounding down here because we obviously can't have part of a box, and we'd have 31 boxes kind of back the way. So total is going to be 4 times 31 times 17. So we get 2,108 boxes if we pack it that way. So kind of we have to then look at orientation 2. So that is where we have the box kind of rotated round. So it's the 40 centimeter side that is matched with the 240, and the 60 will be matched with the 1250. So 240 divided by 40 gives us 6. With the 1250 divided by 60, that gives us 20 and a bit, so always round down, remember, so we get 20 boxes. So the total number of boxes in that orientation is going to be equal to 6 times 20 times 17, which gives us 2,040 boxes. So maximum is 2,108 boxes. Right, so marking for this question isn't as straightforward as some of the other ones. So our first mark for part C here is for showing that you have done 2 different calculations, so that you've tried it both orientations. You get your 5th mark, well, the 5th mark for this question, the 2nd mark for this part of the question, for calculating that with the first orientation you get 2,108, and then your 3rd mark is for calculating how many boxes, so the 2,040, and then making the comment that it is in fact the 2,108, which is more. So we're still going on to part D, following the journey of this tin of beans right from when it started. So let's go. So we have, it takes 277 hours to sail from the UK to Canada. Local time in Canada is 5 hours behind the local time in the UK. The ship leaves the UK at 2200 on the 3rd of June. Calculate the date and local time when it arrives in Canada. Okay, so we start at 2200, 3rd of June. So we can work out kind of in UK time when we get there. So we've got 277 hours. So if we work that out into kind of days and then what's left, so if we divide it by 24, we get 11 full days. And then if we take that decimal that we have and times it, we get that it is 11 days and 13 hours. So if you think about it, 11 days is 264 hours. That's just 11 times 24. And then we can work out how many extra we have on top of that is 13. So we've got our 11 days, which we've got to work out first. So if we add our 11 days, I always like to kind of visualize this rather than do it in my head. So we get still 10 o'clock, and it's going to be the 14th of June. So then we're going to have to add our 13 hours. Okay, so it's 10 o'clock, so to get to midnight, it's 2 of those, so we actually end up with 11 o'clock, and it's going to be the 15th of June. So what I did there is I went to midnight and then saw how many was left. So that is UK time, and it tells us that Canada is 5 hours behind, so that means we're going to have to subtract those 5 hours. So we get 0600 on the 15th of June. That's when that will arrive. So looking at the marks for part D. Your first mark is for calculating this, the 11 days and 13 hours. Your second mark is for getting that it arrives, like the UK time of arrival. And then our third mark is for doing the fact that you've got those 5 hours that you have to take away. You can do it a slightly different way, so you can work out the time difference at the other end. That's totally okay and would still get you all the same marks as long as you get to the same answer. Right, so that's us done with question 9. Let's go on to question 10. Okay, so Fiona is a vet. She started a new job. Her new salary is £42,000. National insurance is calculated on a person's salary before deductions such as pension contributions. For part 1, we have to calculate her annual national insurance payment. So we have to work out how much of her money is where. So our £4,200, looking at these, is in this bracket here, which is nice. So we know that that first £8,164 is not taxed, and it's just the money that is over that up to £4,532 and is taxed at 12%. So first thing we have to do for part 1 is work out how much of her money is actually taxed. So that's going to be that £42,000, which is her salary. And then we're going to have to take away the £8,164, and we get that £33,836 worth of her salary is taxable. And then if we work out 12% of that £33,836, we get that her annual tax is £4,060.32. Right, so for part 2, we have her annual income tax payment is £5,427.96. She pays an annual contribution of £3,360 into her pension. She is paid in 12 equal monthly payments. Calculate her monthly net pay. So we're going to have to work out her annual net pay and then work it per month. You could do it a different way, so you could work out kind of what her monthly deductions are, what her monthly salary is, and do it that way, but that's kind of a little bit extra work that we don't really need to do. So the net pay for annual, that is going to be that £42,000. Subtract your £4,060.32. We are also subtracting our £5,427.96, and also subtracting our £3,360. So once we've done that calculation, we get that for a year her annual pay is in fact £29,151.72. So monthly is going to be that value that we just found divided by 12, which gives us a monthly pay of £2,429.31. So for part A, our marks come from working out this here, so knowing how to deal with that 0% rate up to £8,164. So knowing that not all of her money gets taxed, some of it is tax-free. And then our second mark for part A, the first part of part A, is getting to your answer that her annual national insurance payment is £4,060.32. For part 2 of part A, we get our first mark for getting to her annual net pay, and then the second mark comes for working out the monthly net pay, so for dividing that by 12. Okay, remember obviously this is in the calculator paper. You have the calculator. If you want to try and do stuff by hand, go for it, but check it. Okay, so there's no point in making silly mistakes with your kind of subtractions and things when you've got the calculator there. So we're going to keep going with Fiona's life here into part B. So Fiona plans to rent accommodation. She needs to work out how much she can afford to spend on rent, electricity and council tax. The table shows her monthly outgoings, and we have to calculate how much she will have available for rent, electricity and council tax. So we need to add all those values up, and when we add all those values up, so the car payment, car insurance, road tax, food, clothes, mobile phone, internet, socialising, loan and savings, we get that that is £1,714. So available for her rent is going to be that £2,429.31, and we're going to take away the 1,714, and we get that she has £715.31 available for rent, electricity and council tax. So for that, remember, if you've made a mistake in part A of this question, you can keep going and still get follow-on marks. Don't think I'll just stop because I've made a mistake. You have to keep going. But also here, this is where if you've got that she has some ridiculously low amount of money for rent, that you've probably made a mistake in part A, and that's the time to start to go and look back if you have the time to do so. Right, so we're going to go on and have part C and see what she's going to be doing with that money for her rent. So we've got Fiona's considering 3 properties. We have a 2-bedroom house which has a monthly cost of £730 and includes the rent, council tax and electricity. We have the second option, a 1-bedroom apartment which has a weekly rent of £132, council tax band F and a weekly electricity of £12. And then we've got our 3-bedroom farmhouse, monthly rent of £390, council tax band E and a monthly electricity of £76. So the first one is all inclusive because it's got total monthly cost, it includes everything. So the 1-bedroom is where we're going to have to start working things out. So 1 bed, so total cost for that is going to be, so because it's weekly rent, it'll be 4 weeks in a month. So we do 4 lots of that £132, plus we're going to have to divide our council tax by 12 because that is in 12 monthly installments. So plus so it's band F, so £2,168.64 divided by 12. And then we've got our weekly electricity, so again, going to have to times it by 4. So 4 lots of that, £12. And that comes to our total of £804.72 for the 1 bedroom. So looking now at the 3 bedroom, it's monthly rent, so we've got our £390, and then we've got to add our council tax, which is going to be, so it's band E this time, so £1,834.92. That's going to be divided by 12. And it's monthly electricity, so it's plus that £76. So altogether we get the 3 bedroom is going to cost £618.91. So we can say the 3 bed farmhouse or 3 bedroom farmhouse is the cheapest. Right, so going from there, where do our marks come for this question? Our marks come from, for the first mark for part C, we get it for working out our 1 bedroom cost. Second mark for this is working out the 3 bedroom cost. And then our final one is for making a statement that's consistent with the working we've done. Right, so on to question 11. So we have a new hotel being planned in Benidorm. The pool will have a walkway around 3 sides. The walkway is 1.5 metres wide, which is shown there. We need to work out the total area of this walkway. So there's a few different ways to do this. I think the easiest way is going to be to work out the total of the big area and then take away the area of the pool. So if we think about it, so it's just working out the area of 2 rectangles. So if we work out our first area, so we've got area is length times breadth for a rectangle. So if we do the pool first, actually, because it's easier, that's going to be 8 times 16. So the pool has an area of 128 square metres. So the total bit is going to be equal to, so it's still area is length times breadth because it's still a rectangle. So if we think about the length, so if we go this way, so we've got our 1.5 and our 16. So it's going to be 17.5 times by, if we look at our breadth, so that way, so we've got our 1.5, our 8 and our 1.5. So the two 1.5s come to 3, and we've got our 8 as well, so it's going to be timesing by 11. So 17.5 times 11, which gives us 192.5 square metres. So the walkway is going to be found out by doing that 192.5, take away the 128, which gives us, give me a second while I work this out my calculator, right? I am doing this as I go, I promise. Right, so we get 64.5 square metres. Right, so for this I didn't look at the marking scheme before I did this, I just went and did it the way that I see to do it. And I've picked alternative strategy 2, so there are different ways to do it. There's 3 different ways they've got it here. I've obviously picked, I think, what is potentially the least popular one because it's alternative strategy 2, but that's fine. But for this method of answering, your mark comes from finding your total area and then processing and working out the walkways area, so once you've taken away the pools area. So going on to part B, the walkway is going to be covered in tiles. 16 tiles are needed to cover 1 square metre. The tiles are sold in boxes of 50. Each box costs €71.95, and we need to calculate the cost of tiles needed for the walkway. So we know we're going to have to work out kind of how many tiles we need. So for each square metre, so we've got 64.5 square metres, we're going to have to times that by 16 to work out how many tiles we're going to need. And we get 1032 tiles. So then we're going to have to divide that by 50 because there's 50 in a box. And so we get 20.64, so we're going to have to round that up, so 21 boxes of tiles. So then 21 times by our euro cost of 71.95 €, we get the total cost is 21 times £71.95, it's not pounds, it's euros, and we get €1,510.95. So marks here, your first mark is for working out the number of boxes required, or how to work out the number of boxes required, and then your second mark for part B is for rounding appropriately and calculating the costs, so knowing that you've got to round up because you can't have part of a box of tiles. Right, so on to part C. Okie dokes, so we have to now calculate the volume of the swimming pool. It is a prism with the dimensions shown in the diagram there, and we have to give our answers in litres. So we know for a prism, volume is area times height. So we can do this two different ways. We can split it up. We can work out the area of this face here, the whole thing, and then times it by our length that way. Or we can split it into kind of a cube, like a cuboid, like the top bit, which will be a cuboid, and then kind of a triangular prism at the bottom. Right, so with this, what I'm actually going to do is work out that it is a composite volume. So we've got our cuboid, and then we've got our triangular prism underneath. So for the cuboid, volume is equal to length times breadth times height. Okie dokes. So here it says we need to work out our answers in litres. So litres we can get by working from centimetres cubed. So I would put it into like centimetres when I'm doing this. So the length of the pool total, so we've got 16 metres, so 1,600 centimetres. Our 8 metres is 800 centimetres. And then our depth of the pool is 0.5 metres, so that is 50 centimetres. So we get that cuboid has an area of 64, and then we've got 1, 2, 3, 4, 5, 6, and it's centimetres cubed. Right, so that's a lot of centimetres cubed, but that's the same as millilitres, so if we divide it by 1,000, so if we take off our 3 zeros, we get that it is 64,000 litres. Because a centimetre cubed is exactly the same as a milliliter, and there are 1,000 millilitres in a litre. Right, so then our triangular prism, so for a triangular prism we have volume is area times height. That's for every prism, and for any triangle, area is a half base times height. So we need to work out those measurements. So our height is this bit here, so if we look, it's 4 metres before it starts, and the whole thing is 16. So we're going to have a half. I haven't worked out the base yet, but it's 12 metres, so 12,000. And then our base, so again looking here, it is 2 metres in the deep end, and the shallow end is half a metre. So we go half a metre, and then we've got another 1.5 metres. So another 1.5 metres is 150 centimetres. So if I do a half times 150 times that 1,200, I get 90, oh, what happened there, 1,000 centimetres squared is the area of that triangle. There we go, that's the 9 sorted. And then I've got to take that 90,000 and I need to times it by the length of the pool, or the width of the pool, so the 8, because that's how far back the triangle goes, so timesing it by 800. And I'm going to get 72 million again, centimeters cubed. So again, to change into litres, I can get rid of 3 zeros, so I get 72,000 litres. So my total volume is equal to my 64,000 litres plus my 72,000 litres, which gives me 136,000 litres in that pool. Right, so marks for this. So we need to work out, so you can get 1 mark for showing that you know that it's kind of got to be the 2 volumes, so the cuboid and the triangular prism. Your second mark is for calculating the volume of the first part. Your second is for working out your volume of the second one and working them together. And then for this one, the last mark is for converting to litres. I converted to litres to start with, so showing that you know that centimetre cubed is the same as litres, a way of doing it. I would say it's much harder to swap from metres cubed into litres than it is to change like everything to centimetres and just work with some zeros to start with. But if you did have that metres cubed, you would have to times it by 1,000,000 to change it into centimetres cubed, and then divide it by 1,000. So it's kind of easier to do it at the start rather than at the end, in my opinion anyway. Right, so that is us. We're done. Paper 2 is finished. So thank you very much for watching. I hope that's been helpful. Please comment if you've got any questions about any of this. Again, share it with people in your class if it's something you found helpful. Hopefully it has been. If you've got any comments or kind of advice on how to make these videos better, leave those as well. Like the video, and there will be more videos coming as kind of more past papers happen and I've got the time to do them. So thank you very much for watching, and there'll be more coming later. And again, sorry for repeating myself there. Right, so thank you. Bye.